So example number 66, use integration to determine the length of a curve y is equals to 3 minus x squared between x is equals to 0 and x is equals to 4, isn't it? So we say the length of the curve is given by you integrate from a to b of the square root of 1 plus the derivative of f of x squared dx, where x is between the intervals a to b, isn't it? So you can see we've been told here y is the function of x. Are we together? So if you have y to be a function of x, and our curve there we have y is equals to what? 3 minus x squared, isn't it? See, that is enough to tell you that the function of x is 3 minus x squared, isn't it? So if you differentiate a function of x, function of x, that is f prime of x, you get? See, if you differentiate a constant, you get 0. If you differentiate minus x to x, you get negative 2. 2 times negative 1 is negative 2, you reduce the power by 1, isn't it? Polynomial. So you get negative 2x. But what do we want? We want f prime of x squared, isn't it? Meaning if you square both sides of the equation, you get f prime of x squared. So what you get? Negative squared is positive, isn't it? 2 squared is 4, isn't it? Then x squared is x squared. Meaning if you square negative 2x, you get 4x squared, isn't it? So from there, you go and you substitute it at that point, isn't it? So if you substitute it, what do we get? We find that the length of the curve, this length of the curve is given by from a to b. A will be told between x 0 to 4, meaning x is between the range 0 to 4. So you can see our a is 0, isn't it? We are integrating from 0 to 4, isn't it? Then we are integrating the square root of 1 plus f prime of x squared, which we found to be 4. We found to be 4x? 4x squared. 4x squared, isn't it? dx. Well done. So how do we integrate that kind of problem? If you look at what is there, it's a concept we are used to. We now want to integrate from 0 to 4 the square root of 1 plus 4x dx, isn't it? How do you integrate that? It is very simple. You know when you have 1 plus something x squared, that is usually the Pythagorean identity, whereby when you have sin squared x plus cos squared x is 1. If you divide all this through by cos squared x, you always get 1 plus tan squared x to be equals to sec squared. Are you seeing that? Isn't it? Yeah. To be sec squared x. So from here, you can rewrite this in this form. You are integrating from 0 to 4 square root of 1 plus 2x squared with respect to x. So that both 2 and x are inside the bracket. So that you can say you let what? You let 2x to be tan t. Are you seeing that? So that you are going to have 1 plus tan squared t. Isn't it? Are we together? You let what is inside this bracket 2x to be tan t. So we are now going to have 1 plus 2x squared is just 1 plus tan t squared. So that means you have 1 plus tan squared t in short, isn't it? What is 1 plus tan squared t? See, that is sec squared t, isn't it? Yes. Pythagorean, isn't it? So we've seen that. Now we want the square root of 1 plus 2x squared. Is the square root is what we're looking for, isn't it? If square root is now square root of sec squared t. Square goes with root. This square goes with the root. You remain with sec t. So what have we found? We found that this square root of 1 plus 4x squared is simply sec. It's just the same as sec t. So it means what we need to look for is the x we are transforming, isn't it? What we need now is the x, isn't it? Are we together? What is the x? So you come here, you say 2x was equals to tan t. So see here, if you differentiate x with respect to t, what do you get? See here, you get 2 dx over dt. See, 2 is a constant. You differentiate x with respect to t, you get dx over dt, isn't it? Then you differentiate tan t with respect to t, you get sec squared. If you differentiate tan, you get sec squared, isn't it? You differentiate the inner function, you get 1. Then you remain with, you are differentiating t variable with respect to t, you remain with dt over dt silent, doesn't it? Are we together? Yeah. So if you take dt the other side of the equation, it means what do you have? You have that 2dx is equals to sec squared td. If you take dt the other side, isn't it? 2dx is sec squared td. dt. So you can see for you to remain with the dx, you divide both sides by 2, you get dx is a half sec squared t dt. You are done. Now we now want to use that to integrate that. We do substitution, isn't it? Do the substitution. That is now what we want to use. So can you now start? You have made it indefinite first. Leave that limit 0 to 4 first. We want to start to get the integral, isn't it? Of indefinite. So if you are integrating square root of 1 plus 4x squared dx, substitute the square root of 1 plus 4x squared. You found it to be sec. You found it to be sec t, isn't it? Yeah. Then dx you found to be half. Then you factorize outside a half. Then you put sec squared td, sec squared tdt. That is dx. So you substituted square root of 1 plus 4x squared, which is sec t, and you substituted dx, which is a half sec squared dt. So are you seeing? This is integration by parts. You are integrating. We say for you to integrate sec cube, you manipulate it in a manner that it is 2 functions, isn't it? You can recall how we integrated sec cube in integration of trigonometric functions, isn't it? So you say, here you can see this is the same as what? What is this? It is the same as saying a half integral of sec t times sec squared t is what? Sec cubed t dt, isn't it? Are we together? So how are we integrating sec cubed t dt? See, we were separating it the way it is separated there. Are we together? Meaning this a half sec cubed t dt is a half sec t sec squared t dt. So this is integration by parts. U dv. We show that if we use integration by parts in this manner by manipulating it in this manner is when we can get the derivative, the integral of sec cubed t. Is that okay? So start. What is u? U is equals to sec t. So if you differentiate u with respect to t, if you differentiate sec t, what was sec t? So it is minus v du. V tan t times du, you get sec tan squared t. Sec t tan squared t. So it means the whole of this thing, and remember a half is outside, isn't it? So if you put your half, which was outside on both sides of the equation, if you put your half, it will be a half of that, a half of that. So a half u dv, the whole of this is now that. Are we together? So after getting the whole of that, substitute it there, you have a half integral of sec cubed t dt. We found it is the same as a half sec t tan t minus a half sec t tan squared t. Integral of sec t tan squared t dt. So it is a half sec t tan squared t dt. But what is tan squared t? See, tan squared t is 1 minus is sec is x squared t minus 1 dt. Why? Because 1 plus tan squared t is equals to sec squared t. Meaning if you take 1 the other side, you remain with tan squared t to be sec squared t minus 1, isn't it? Yes. So where we have tan squared t, we put sec squared t minus 1. We put sec squared t minus 1. Open that. So if you open that, this side we have a half sec cubed t dt to be equals to a half sec t tan t minus a half sec t times sec t times sec squared t sec cubed t dt. When you bring that dt inside, isn't it? Then negative into negative is positive. Then a half times 1 is a half. Then integral of sec t times 1 is sec t. Then dt. So you separated everything. Meaning sec t times sec squared t, you get sec cubed t. Sec t times 1, you get sec t. Then negative a half times t, negative half times 1 is positive. Then you are dt. You separated them, isn't it? Are we together? Now see, this integral here, look at this one. This integral and this integral are the same, meaning you bring this one on this side of the equation, isn't it? So negative a half coming on this side, it becomes positive half, isn't it? Are we together? So you get a half plus a half, meaning you have 1, isn't it? Are we together? So you are connecting the right terms. That is what we are doing. Negative coming this side is positive. So half plus a half is 1, meaning you now have integral of sec cubed t dt to be equals to a half sec t tan t plus a half. Now see that when you integrate sec t is when you get ln of sec t plus tan t. Then you go back. What was your t? What was t? You said 2x was tan t, isn't it? Yes. 2x was tan t. So if 2x was tan t, then where there is tan t, that is direct. Where there is tan t, you put 2x, isn't it? See there? Yes. Where there is tan t, you put 2x. And where there is sec t, what do you do where there is sec t? It's very simple. This is what you do. If t is equals, if 2x is equals to tan t, then it means t is tan inverse of 2x. When you take tan the other side, isn't it? T is tan inverse of 2x. Or you leave it like this, but now you change the limits. The limits of x was from 0 to 4. Are we together? You leave it like this, but now you change the limit. So we now want the limits of this integral. You leave it like this, but you change the limits. When x is 0, what is t? Are we together? When x is 0, what is t? Meaning 2 times 0 is 0 is equal to tan t. So t is tan inverse of 0, isn't it? You get t to be tan inverse of 0, which you get to be tan inverse of 0 is 0. So the upper limit, the lower limit of that is 0. Are you seeing? Then you see, when x is 4, what is t? Because 2x is tan t, meaning you have 2 times 4 is 8. 8 is equal to tan t, meaning t is tan inverse of 8, isn't it? So you get tan inverse of 8 to be, you have 1 point, and remember, your calculator is in R, meaning this 1.446 is in pi radians. Are we together? Your calculator is in? Yes, the answer you are getting is in pi radians. So if you put your calculator in degrees for you to see what is equivalent to that, isn't it? You found it in pi radians to be what? 1.4 46 in pi radians, isn't it? Now see, if you are, for instance, if your calculator was in a D, this is what you are going to get. You are going to get 82.8987 degrees, isn't it?
Yeah.
If you divide by 180, you are going to get 0.446 pi radians. So can you multiply 0.46 times pi? 0.46 times pi. What is pi? So you see you are getting the same answer. So you stick to that pi radian until the end. You don't change it back to degrees, okay? So it means 0.46 pi is the same answer you found, which is the upper limit, 1.446, which is in pi radians. Is that okay? Are we together? So we are now integrating from 0 to 1.446, which is already in pi radians, isn't it? So what do you get with the answer? Substitute upper limit minus lower limit. You get upper limit